what each of the transformations do, okay? First of all, when you have f of x plus h, right? The plus h is inside with the x. What does this do? Moves left h units. So the other one will move right h units. This one, it moves up. So moves up k units. So that's super important, that if it's outside, it goes with the sign, right? If it's inside, it goes opposite to the sign, okay? And so the other one will move down k units. Okay, the next one, negative f of x. This one, for example, is if you have y equals negative absolute value of x. So the negative is outside of the function. This is a reflection in the x-axis. Okay. The other one, it's f of negative x. So for example, right, if you have y equals, like if the negative is inside, right? So for example, you know, negative x, like inside, okay? This is a reflection in the y-axis. Okay, now, when you have a times a function, so 3 times the square absolute value of x, and so on, there are two situations. One is if a is greater than 1, that's a vertical stretch. Like we did it yesterday. Who was asking that?
Was that the?
Oh my God, and the door is locked. Okay, so I got it. It was the settings, you know, like extended versus not. Somehow we went back. However, I am gonna put in a ticket, I think, because I'm having trouble connecting it like wirelessly.
Okay.
So maybe at some point we can take a
Sure.
look at it. But this one,
Okay.
I got it. Thank you so much. Sorry about that. We got it right when you left, but since I collected all the phones, I couldn't call you. Okay, so vertical stretch, right? It stretches upwards like this. When a is between 0 and 1, so for example, if you have, let's say, y equals 1/2 absolute value of x, this is a vertical compression. Okay, now, these, right, if you have f of b of x, that's a horizontal compression and a horizontal stretch. So, and these are opposite. So if it's b is greater than 1, it's a horizontal compression. No, it's not funny. It's just a horizontal compression. And then this is a horizontal stretch. Okay, now, later on, when the functions get a little bit more complicated, we're going to revisit these again and again and again. Right now, you have to know these, okay, the vertical ones, and the other two we're going to focus on later.
The vertical stretch and compression, isn't A just the slope of the line?
For absolute values, yes. And then when you have parabolas, since it's not a linear, we can't really talk about slope, then it's a little bit different. But yes, for absolute values, definitely the slope. Okay. Now we're going to talk about, we're going to move on from absolute values to quadratic functions. The first one we're going to take is f of x equals x squared, right? This is the parent function. So again, I'm going to pick values for x and y. And again, you want some negatives, you want some positives, you want a 0. So -2, -1, 0, 1, 2. All right. Okay. It's time. You've got to be super careful with squaring negatives, right? So if it's y equals x squared, this is going to be the whole x value, -2 squared, which is a +4. -1 squared is a 1, 0 squared is 0, 1, and then 4. So you see how there is, symmetry again, right? Starting from 0, it's 1 and 4, right, to the left, and 1 and 4 to the right as well. So at 0, x is 0. At -1, x is 1. At -2, x is 4. And then the same numbers are mirrored on the opposite side. So it looks like this. Okay? This point here is called the vertex of the parabola. So notice, again, for the parent function, the vertex is at the origin. So when you have a translation, you're first going to move the vertex. Okay? Now, what else do we know here? First of all, what is the domain? All real numbers. And the range is y is greater than or equal to 0. Okay, what else do you notice here? From the vertex, if you go to the right 1 unit, how much do you go up? 1. Okay, so here's how that factors in. If you go over to the right 1 unit from the vertex, you go up that number squared, 1 squared. Now, if from the vertex you go over 2 units, you go up 2 squared, which is 4. Okay? And that's how you can do all of the other parabolas. Like that's sort of like the, quick way of doing it. Okay, so here, where does the -5 move the graph? Down 5, down 5. Okay, so at this point, right, the vertex now is no longer at 0, 0, it's at 0, -5. At this point, to graph this parabola, you have two options. One is you can quickly plug in a value. For example, when x is 1, y is 1 squared minus 5, -4. Okay? When x is 2, y is 2 squared 4, minus 5 is -1. Or you could do the same thing. Go over 1 unit means you go up 1 unit. Go over 2 means you go up 4. It's the same exact thing. And then to the left, you mirror, and that's how the parabola will look. Okay? All right. Obviously, you can't draw a parabola using a ruler, but in the next one, I'm going to show you how to make it look, really nice. So x squared plus 4, it moves up. So the new vertex is now 0, 4. So again, if I go over 1 unit, I go up 1. If I go over 2 units, how much do I go up? 4. Or you can plug in points. Yes, it's only if it's, y equals x squared something. Okay, so how to make it look pretty? This is not an absolute value graph. So if that vertex is a corner, you will not get full credit. You have to make it, curved. So the way I like to do it is I kind of do like that bottom curve first, so it is curved, and then extend upwards. But again, right, make it, it's not like it's drawn with a ruler, right? It's got to look like a parabola. Okay, so here, where does the vertex go? 0, 4 will be up 4. Which way does it go? Up, down, right, left? To the right 4 units. So at 4, 0. Here. And then again, okay, so let's do this one by plugging in points. If you plug in 1 point to the right of the vertex, x equals 5. Y is 5 minus 4, 1 squared. And then here you mirror it. If you go 2 to the right, x equals 6. 6 minus 4, 2 squared, 4. Okay? So we're mentally plugging them in. You've got to be able to graph these relatively swiftly. Okay, I don't want to use the word quickly because I don't want you to like rush through it, but it's got to be like, nice and smooth. Okay, x plus 6 squared. Where does the graph move? To the left, how much? 6 units. So the new vertex is -6, 0. Here. Right? Put 1 point here, then go up 4 for the other one.
So you go over 2 up 4.
Right. And we can do that because so far there are no stretches or compressions. Okay?
Can we do the same thing for like cube instead of just choose a number? So like
Mm-hmm. But cubic functions look different, right?
are those the
Right. Mm-hmm. Same idea. That's why I like to teach it this way. So, you know. Okay. Now, this one here is what type of, it's a vertical stretch. Okay, so what's the vertex going to be? Has it moved anywhere? No, so it's going to be 0, 0. Okay. Where did it go? Okay. Okay, now for the first one, I want to do a table, right? So let's do X and Y. Okay, so we're going to do -1, 0, or you know what, let's do -2, -1, 0, 1, 2. I mean, we already know the 0 anyway, right? Okay, so if you plug in a -1, what are you going to get? 2. Okay, so let's focus on the symmetry. So if you plug in a -1, you're going to get 2, right? This is 0. To the left, you're going to get 2. Now, if you plug in a 1 on the opposite side, you're also going to get a 2, right? So 2 and 2. Okay, so let's take a look at what happened. We had said if you go over 1, you go up 1 squared. But now it's all multiplied by 2, right? So instead of going up 1, you go up 1 times 2, 2. Okay? So let's plug in the -2. What are you going to get? 8. And also for 2, you should get 8. So what we had said before is if you go over 2, you should go up how much? 4, right? But now it's times 2, so you go up 8. Okay? That's how it's stretched, right? Instead of going up 2, now you're going up, instead of going up 4, now you're going up times 2. It's stretched upwards. Okay. So, all right, let's graph this one. That's how that looks. You see how much narrower it is. Okay, so the other one, let's plug in some points. The vertex is again at 0, 0. Okay. So look, this time I don't need to include 0, 0 here, right? So let's just go to the left and right, 1 and -1. Okay, and then let's go to the left and right by 2 points, 2 and -2. So what do we get when I plug in the 1? 1/4 and -1? 1/4. Okay. And then 1 and 1 and 1. Okay. Now, if fractions are not your thing, okay, you could also, instead of plug in the 1, right, you could just plug in a 2 and a 4, because then you'll only get numbers that are divisible by 4, and then you'll get like integers, right? So instead of plugging in the 1, look, if you plug in the 2, you get 1. What happens if you plugged in 4? You get 4 squared is 16 divided by 4. 4. So, you know, you get like integers. Now, let's do it the other way. I had said if you go over 1, you should go up 1 squared. But this is being multiplied by a quarter, so you go up only a quarter. We had said if you go over 2, you should go up 4, but a quarter of that, you only go up 1. You see how harmoniously it all works together, right? So whether it's by points or the other way, it really doesn't matter to me. Just do it correctly, okay? All right, next one. Okay, -x squared, what happens to that one? reflection in the x-axis.
Was it E down?
Yeah. So the vertex is still 0, 0. Now, if I plug in 1, I'm going to get -1. And this is important. Okay, a lot of people kind of had trouble with this on the quiz. If you plug in -1, this is going to be -1 squared, so it's -1, right? Don't go canceling those negatives. Okay? And then the next one is going to be -4 and -4. Again, either points or the other way, it's up to you. Okay, look at that one. How exciting is that one? Right? So it moves where? Left or right? Left and down. And there is a reflection, and there is a vertical what? Stretch or compression? Compression. So if I were to ask you describe the transformations, you would say left 3 units, down 5, reflection in the x-axis, don't just say reflection please, and a vertical compression. Okay, so what's the vertex then? -3 and -5. Okay? Who else was an ambassador last night? I know Aaron was an ambassador. Who else? It was just you. You were doing a very good job ambassadoring. Yeah. Okay, so the vertex is at -3, -5. Okay. Now, at this point, you can plug in points, or you can, do it the other way. All right? So let's try to plug in points. Because I want you to know what points to plug in. The vertex is at x equals -3, right? When you plug in points, it's best to plug in like 2 to the right and 2 to the left, right? So 2 to the left, that would be -4, -5, and then 2 to the right, that would be -2 and -1. Okay? So it's at x equals -5. It's at x equals -3. I go 2 to the right, -2, -1, and then -4, -5. All right? Okay, so when we plug those in, you got to be quick about it, right? You shouldn't spend too much time on this one. So if it's -4, when you plug it into the parentheses, that's going to be -1/2 times how much? 1? -1 squared, right? -5. Okay, so how much is that? -5.5, yes? Okay, so that's -5.5 right there. Okay, so that means what is it going to be at -2? -5.5 again, because it's symmetric. Okay? All right, what about if you plug in a -5? So now you have -0.5. -5 plus 3 is 2 squared, 4, -5, so that's -7. And -7. Okay? Okay, now, let me show you another trick to make your chart so you can see the symmetry a little bit better. What was the vertex? X equals what? -3. Okay, so put in the -3 and then do the other ones symmetrically. Right before -3, it's -4, and then right after it, it's -2. And then if you go one more, it's -5 and -1, correct? So now this way, you plug in -4, you get -5.5, and you can just do it symmetrically here. And then if you plug in -5, you get -7, and you can do it symmetrically here. Like, okay? Right? So this is -3, here. And then we plug in 1 to the right and 1 to the left, like this. Okay? All right. So this is, everything in all its glory, right? This is how the functions can look. F of x is plus or minus a times absolute value x minus h plus k, or the square root version. All right. Let's talk about how to come up with functions. Okay? So, to write functions, you're now going to use the two templates that I just showed you here, and you're going to come up with all of these values. Okay, so first of all, when you have h and k here, those are the vertices. Okay, so take a look here. What's this point right here? 5, -3, correct? This is your h and k. Okay, now, if you've got an absolute value, it's sort of easier because all you need is now the slope, right? And if you look at the slope on this side, it's what? M equals how much? 2. And then here, it's m equals -2, right? It's got to be because it's symmetric. Okay, that will be your a. So now, to build your function, first and foremost, you need f of x, because then it's not a function, it's just symbols. Okay, that slope 2 is your a. So you say 2. No, just 2, because it's enough to go right and left. 2 x minus h minus, no, not plus or minus. It's, you just take the minus will have reflected it downwards, right? You have a minus if it's reflected downward. Right. You use a plus if there is no reflection. You use a minus if there is a reflection around the x-axis. Okay, let's just go with this one. Please don't interrupt me in the middle of them. If you have a question, please raise your hand, right? Because then everybody's train of thought is interrupted. Okay, thank you. So 2x minus 5 minus 3. Okay, a x minus h minus k, or plus k. Okay, next one. Next one, you have a parabola, so it's a little bit different. There is no slope. You still have a vertex though. What's the vertex here? -3, 4. Okay, so this is your h and k. Okay, now you have to figure out what a is. In order to figure out what a is, you need to pick a point on the parabola. All right, so to pick a point on the parabola, we're going to pick this one. Okay, -1, 2. Now that becomes x, y. Okay, now, again, don't get hung up on the plus or minus. It'll fix itself. The math will fix itself. So we're going to do this. F of x is equal to a x, right? Exactly this formula, minus h squared plus k. Okay, what's another word for f of x? Y. So we say 2 equals a, -1 plus 3 plus 4, right? We plug in h and k and x and y. So this is x and y, oh, squared, sorry. X and y and h and k. Okay, so now you have all the numbers except for a, and we're going to solve for a. So 2 is a times 2 squared plus 4. 2 is 4a plus 4. Subtract 2. Minus 2 is 4a. Divide by 4, divide by 4. A is equal to -1/2. Okay? So now we can build the function. You see how the negative just came out of the math? Okay, hang on. Okay, Isabel, let me take you first.
Oh, wait, no, minus 4.
I subtracted 4.
Yeah.
And then I divided by the other 4.
And you just see, like, if this was a normal parabola, you go to the first one over, see that number, like, if you go to the right one, you go down 1/2.
You can, the 1/2 is a little tricky though, because it could be a 1/3 as well. You know what I mean? But you have to do more to check. However, if I ask to show work, you should show some sort of work, right? Either like an explanation or something. Okay, so f of x is going to be negative 1/2 x plus 3 squared plus 4. Okay, any other questions? Yep.
How do you know when it's x minus h and x plus k? Is it always?
It's always x minus h plus k. Always. Okay, this one. What's h and k? Yeah.
How do you know when it's absolute value or parentheses?
So you have to look at the graph itself. When it's a parabola, like the curved parabola, then it's the quadratic, and then it's that one. So, okay, so here, this is 7 comma negative 6. We're going to pick another point here, 5 comma 0. Okay, that's your x and y. This is a parabola, so it's got to go into the parabola equation. Are you going to get those equations on the test? Of course not. You have to have them memorized, right? So f of x, which is y, 0, is equal to a x minus h squared plus k, which is negative 6. So we just do negative 6. Okay? All right, so 0 equals a times 2 squared, that's 4a minus 6. Add 6 to both sides. 6 is equal to 4a. Divide by 4. Divide by 4. A is equal to 3 over 2. This time it's positive, right? So we get f of x is equal to 3 over 2 x minus 7 squared plus 6. Okay, now, hang on. Before I take your question, very, very important. Take a look. In the parabola above, do you see how the parabola was facing down? It's supposed to be a minus 6, sorry. Sorry, minus 6. Okay, look at the first one. Do you see how the parabola is facing down? Yeah? When I solved for a, I got a negative number, which is what should have happened because negative a means reflection downward. This is a parabola facing up, and when I solved for a, magically I got a positive number, right? Which is what should happen. So this is one way to check yourself. If you added or subtracted incorrectly, or if you have a negative sign somewhere that went wrong, and if you get the wrong sign for a, at least this is one way you can figure this out. All right, I'm gonna do D as well, and then I'll take questions. Write them down if you have questions. Okay, we go to the vertex. How much is the vertex? Right. Okay, so for this one, what process am I going to do? Yeah. What do I do? It is an absolute function, so what do I do? The slope, right? Slope is the magic word I'm looking for. Let's find the slope. How much is the slope here? It's negative 1/3 on this side, right? And then positive 1/3 on this side. So now, f of x is equal to, is this absolute value graph facing up or down? Down. This has a reflection, so it's going to be negative 1/3 x plus 4 minus 3. Okay, that's that lesson. Okay, now I'll take questions. Okay, let's start with here.
Is there an equation for the absolute value one?
There is. It's here. They basically look the same, right? Do you see how this one is for the absolute value? And then this one is for the parabola or the quadratic. Okay? They look the same. Like the A, the H, the K are all the same. It's just one is an absolute value, one is a square, and then you'll notice later for exponential functions, for all of the other functions, it looks the same. Yeah.
For the absolute value function, we have to show work, so all you have to do is find the slope.
All you have to do is find the slope.
So, should we write that down?
You can. Okay, yes, and then Lexi, and then I'll go.
Did you do none on C? It's just like that. In the parentheses, is that 7?
Yeah.
Okay.
Lexi, did you have a question? Oh, okay. Yeah.
So from the equation, like, where it tells you the equation, it says plus or minus, do we have to